Hello and welcome to the session. Let's continue our discussion for subsequent topic called as set interface or set section. Now set section has certain advantages and certain changes as compared to other, let's say, the list interface and queue interface. So let us see what is there in the set interface. So set interface, it is a mechanism to store non-duplicate elements. So basically duplicate elements are not allowed in set interface. Why is it that? We will see. It is an unordered collection. Basically, it does not maintain the order in which the elements are inserted into it. Okay, it does not allow you to add duplicate elements. Duplicate elements are also not allowed. It allows you to have null elements, which is okay. You cannot access any element by index. Why? Because as it is said earlier, it is unordered collection. So there is no index maintained. So that is why you cannot access any element with an index. So what is set in a nutshell is basically it contains only methods which are inherited from the collection interface and adds restriction of duplicate elements, and that's all is there for set interface or set data structure is basically do not allow any duplicate elements. Now if you see set interface is implemented in HashSet, and that is again extended by a linked HashSet class. And also we have sorted set which implements this interface, and again it adds some other abstract classes. So basically it is extension of these interfaces and some additional methods, and that we can use as a tree set. So we will see with an example the differences and all. Now let us see what is HashSet. So HashSet is one way of implementing the set interface. Now if you see the right hand side, new HashSet, and this is the way in which HashSet is instantiated or is object is created. Hash set and set, these are under java.util packages where all other Java collection framework resides. And so as simple, you can add elements. And if you see now sales underscore 001, so I'm adding duplicate. So now what happens is the moment you add a duplicate element, the duplicate element will actually replace the original element. That means you are not allowed to add multiple duplicate elements. Now, partial answer to this is basically it does not maintain any index. Now, in the list interface, if you see, it maintains the index. So there are multiple elements which are having the same value or duplicate value is allowed. But in set interface, since there is no index maintained, so whatever is duplicate, that will be just replaced, or there is no extra duplicate elements maintained. Now, as we discussed, their null elements are also allowed. Now, normal methods, you can add element, you can remove element, you can get the size, and you can check whether it contains the particular element or not. Unlike list interface, we can do iteration using this enhanced for loop, and we can use this iterator interface as well to iterate through each and every elements of the iterator. Let's see if it runs. Right, so you can see it has done some data processing. Now one more point to note here is again the left hand side and the right hand side. So if you see the left hand side here is an variable of the hash set class, whereas in the next statement this is a variable of the set interface. So both statements are correct, both are also used, but as a normal developer, as a good practice, we normally have left hand side as an interface variable and right hand side as a object of a particular class. Hash set example. So now if you see, this is one hash set where the name is original and another hash set. So now why this there are additional advantages in using hash set is are these one. They can be used for mathematical operation, for example union, intersection and subset. So union is to get the union of two sets a and b, so we can say a dot add all y. So whatever is there in a, whatever is there in y, and whatever is not common in those, that will be available once you add it. You will see with an example also. Here it should be b. Okay, intersection to get the intersection of two sets a and b, we can use retain all and b. And subset is to check if a is a subset of b, so we can use b contains a. To check if A is a subset of B, we can use this contains all. Let's see with an example. So I have original and another. Now let us see the union, let us see the interaction, and let us see the subset. So interaction is with add all, retain all, and contains all. Okay, so these are the original two. So if you see here, union of two is basically Singapore is there, Tokyo is there, London, Paris, Miami. So whatever is not common, that is added here. Right now, if you see interaction, intersection, so intersection is if you see both contain Paris, so whatever is common to them, that is intersection. And what is subset? So subset of this thing, so there is no subset, so it's basically false. So it contains all another. So obviously org does not contain whatever is there, whatever everything is there in another, so it is false. Right, so now another class, list linked hash set. Okay, linked hash set is here, so which is basically extending this class hash set. Linked hash set, it is simply ordered version of hash set. One simple line, ordered version of hash set, that means it will maintain the order. So linked hash set, it does not maintain the index of the element. So to reach to the individual element, we still need to iterate. Now it is basically ordered version of hash set. However, whatever is there inside the set interface, whatever subclasses and all the other interfaces under the set, they do not maintain any index. Okay, they can maintain the order but not the index. Now linked hash set, we will see with an example. Linked hash set is here. So left hand side is linked hash set, right hand side is linked hash set. Now I have added some element, I have removed one element. I'm just iterating, and then again add, remove, using iterate interface. So basically it is the same thing as hash set, except that it is maintaining the insertion order. Okay, so if you see here, I have entered 221B Baker Street, Westminster, England. So the same way the order is maintained. Okay, the way they are entered, that is uh, that is maintained. Whereas if you see this example, or let's say this example, so I have the order is London, Paris, Miami. Now let us run it and see what happens. London, Paris, Miami. So in this example, Tokyo, Paris, Singapore. So if you see Tokyo, Paris, Singapore, so the order is not maintained. If you see in this example, Tokyo, Paris, Singapore was the order, but actually it has printed in a different manner. So the order is not maintained, but in the linked hash set, at least the order is maintained. That is why linked hash set. Okay, tree set, it implements sorted set interface. We have seen it here. Tree set is basically implements the sorted set. Okay, so it implements the sorted set interface. It maintains the insertion order, but not the index, just like the linked hash set. It sorts the element in ascending order on the fly. This is important. If you want to have, if you want to just insert the elements and on the fly, you want to know the sorted, on the fly, you want to sort the elements, you implement the tree set. Okay, let's see with an example. Point to note here is it does not maintain the index of the element. So if you want to reach to that particular element, you need to still iterate. So let us see tree set example. If you see here, the insertion order is A, Z, Q, B, B, U. Now the advantage in a tree set, the advantage in tree set is the elements, the elements what I add, those will be automatically sorted on the fly. So whenever you print this, you will always get the sorted tree set, sorted elements. Okay, let's see with an example. Right, so if you see my order of entry was A, Z, Q, B, B, and U. So it has said A, B, B, Q, U, Z. So this is automatically sorted in ascending order. So that is important. In tree set, you can get the elements which are already in sorted order. Or it will be sorted on the fly. Now again the same terminology here. So if you see right hand side is I'm creating an instance of the tree set class. Tree set class is this one, but left hand side is basically can be a variable of the tree set class, or left hand side could be a variable of the set interface. Both the things are fine. Both the thing should work. Okay, it should work. Okay, so let's see the discussion about the queue interface and other topics in the subsequent sessions. Thank you.